All right, we are going to walk you through our final project. It's called Rotten Potatoes. It is a movie recommendation engine, and it will provide you five movie recommendations based on a movie title, either using keyword similarity or ratings similarity. Different algorithms for each of those. Mohsin is going to cover the back end. I'm going to start off by talking about the front end. So we have two HTML pages used for the front end. One is this one here, home.html, which is the home page of the application, what you see here. And at this page, the user inputs the name of a movie as well as whatever parameter, either keyword or ratings, that they want recommendations based on. I achieved this using two radio buttons for keywords and ratings, and another text box to input the name of the title. This gets used by the application.py, and using the engine's get recommendations function here, it receives the text from the previous submission along with whatever parameter the user chose, and it sends that to the backend to be processed and to come back with whatever recommendations. And all of these are then displayed in the second HTML document, the submitted form document, and we will see that later on when we do a demonstration of the application. So going back to the application.py, this is the segue from the front end to the back end is right here when we create the engine, and we send in the title of the movie along with the parameter used for the search. So Mohsin can take over and talk about the back end.
Okay. So yeah, on the back end, there are two main Python source code files used to process and analyze the data. So to start off with, we sourced our data for this project from the movies dataset, which can be found on Kaggle, the link for which will be included in the final report. The data.py file is responsible for the movie data class, which holds pandas data frame for the movies, the keywords, and the ratings. Keywords and ratings are used in either of those recommendation methods. So on initialization, the data is extracted from the CSV files, which are included in a data folder, and the data is pre-processed here during the pre-processing step. And at this point, all unused columns are dropped, some of the data is cleaned, any values are removed, and it is essentially reduced to a point where we have a concise amount of data that can be used to determine our recommendations. The same goes for our ratings and the keywords, which are gathered and concisely put into data frames to be used during the recommendation step. The engine.py file is responsible for the actual recommending, and upon initialization, the engine class holds an instance of the movie data class, and upon creation, this movie data class will gather all of the CSV files, import the data, and do the pre-processing. There are three similarity metrics that we use to determine similarity when trying to find recommended movies. And then there are a few different algorithms that are used during the actual recommendation step. As Nivethan mentioned, this get recommendations method is called in the main Python file over here, and the title, the K number of movies to return is passed in, and as well as the option and a metric, which is defaulted to cosine similarity. So based on the option, whether it's keywords or ratings, either rec keyword or rec rating will be called. The keyword algorithm gets the list of movies, and every movie has an associated list of keywords. And our algorithm essentially finds those movies which have the most similar keywords to the movie that we inputted. This is done using the intersection method here, which finds an overlapping list of keywords. The movies, the number of overlapping keywords is stored here and stored in a list of tuples. This list is then sorted in reverse order to get those movies with the most keywords in common, and the neighbors are returned and returned back to the application over here in this top variable, which then prints out the recommended movies. The other option is to search by ratings, and ratings takes in the array of ratings, every row of which is a movie and has all the ratings for a number of users. And we use a k-nearest neighbor algorithm approach to calculate the most similar movies in this fashion. Rec rating does a similar thing where it gathers all the movies and calls a helper function neighbors rating, which goes through every movie, compares each movie in our data frame to the movie in question, specified by this movie ID, and then all the movies indices and the distances are appended to a list of tuples. The list is then sorted, and the top k neighbors are returned here. So yeah, both of these methods function as expected, and overall we found that the keywords similarity metric function a little bit better, which we'll get into when discussing the results. Nivethan, if you want to talk about some of the challenges in the front end.
Sure. Some of the challenges in the front end included returning the correct situation that was given back by the recommendation. For instance, there are three possible outcomes, and we talk about this in the report. Either the film was not found in our data set, there were insufficient ratings to provide proper recommendations, or the third and most desirable situation would be having 5 recommendations actually come back from the back end. So we implemented a way for there to always be an array returned with some content. In the case the film is not found, the backend will send back through the get recommendations function an array with just a single string film not found, and if that's the case, then we print out that the film was not found. Same thing for the insufficient ratings here. And if there is a full template, a full array of 5 movie recommendations, then those all get printed out. Some further challenges actually included deploying the project to the web. We originally tried using Google App Engine. This had several shortcomings though, particularly with size limitations for the files. We kind of overcame that by, for instance, our movie data set was too large, so we zipped it up and had the application unzip it while it is executing. But we're also having some issues with different Python versions. It seems like Google App Engine uses Python 2.7, and there were some discrepancies with the libraries we used. So we scrapped Google App Engine and deployed the project to Amazon Web Services instead. So we can go do a test run now and see how that goes. So this is the home page, the home.html that I talked about earlier. So let's try the movie Outbreak. We can search it by keywords. Might take a second and it'll come back. So there we go. This is the submission form .html that I was talking about earlier. So right now, using the keyword, the parameter specified by the radio buttons, we are getting back 5 recommendations, which come back in an array of strings. We could also try this again using ratings. And like Mohsin was saying, the keywords tends to send back a little bit more consistent ratings. For instance, when we try doing Jumanji using ratings, this is an example of there being insufficient ratings. As it will alert us. And then here's an example of if you put in Kill Bill as opposed to Volume 1 or Volume 2, this is actually not a movie title within our data set, and it will alert you to that as well. So, is there anything else you wanted to touch up on, Mohsin?
Yeah. So, as you can see in the demo, and as it's explained in the final report, the keywords metrics seem to return better results overall, and the reason we believe this is because the keywords are more indicative of the plot and content of the movies, so they're more likely to return movies that are similar in content to the movie that is inputted, whereas the ratings is primarily judging based off of the similarity of a user's ratings across of all the users' ratings across a certain movie. So the movie might not be similar in content, but it might be similar in ratings. A good way to think about this is to think of keywords returning similar movies to this, as you might find on Netflix, whereas ratings returns movies that other users also liked. So they're two slightly different metrics, but we found that keywords function a little bit better for our purposes. And another just set of challenges associated with this project is because of our limited hardware and our limited runtime capacity, we had to use an abbreviated data set. So our keywords information and the ratings information aren't as robust as we would like them to be. But and in addition to that, both of the data sets that we used are static and pulled from a static source, whereas looking forward to the future, any recommendation engine that we would continue to work on, we would want to be dynamically updating with any new movies being added or any new ratings being added, so that we could see the overall trend for a movie as well, rather than just a static instance. So those are some of the challenges that we encountered that we would definitely be able to improve on in the future.
All right. Well, thanks for watching.
All right. Thank you.